Cool. In 1985, there was a paper published by Gilovic, Valoni, and Tversky, The Hot Hand in Basketball, on the misperception of random sequences. It's a highly recommended paper. And essentially, it's set off this debate on, does momentum exist in sports? What I mean by momentum here is not your mass times velocity, it's not physical momentum. Talking, and not quite the concept of psychological momentum, which is pretty much where most of the research has been concentrated in this area. I'm really talking about in-game momentum in the sense of this apparent phenomenon that at any given stage of the contest, one player seems to have the upper hand over the other, or one team seems to have the upper hand over the other. So that's what I mean by in-game momentum. So does it exist? If it does exist, can we model it and visualize it in a meaningful way? And the objective really of this research is to kind of operationalize it. So in other words, model it as a function of in-game variables. In the case of Rugby Union, it would be things like the territory gained in a particular phase, the position on the field, the time left in the game, the score difference, and other covariates. My research is also very much focused on presenting this to stakeholders within performance analysis systems, and it's quite a challenge. There seems to be, at least in Rugby Union and at least in South Africa, seems to be a undercurrent of mistrust of analytics, and so it's quite a challenge to present whatever you have done, presented in such a way that is easily understandable by those stakeholders. So I took about 6 months of emails and Skype calls to access some proprietary data from a well-known sports company. It's a very rich data set. This is just a subset of it. There's about 23 variables in total, but as an example, you'll have a fixture ID identifying the game, a period ID is whether it's the first half or the second half, a player ID, a team ID, the time, right? And then you have the actions. And in the case of rugby, there's 29 different actions, everything from player kicks the ball, passes the ball, a scrum, a line out, and so on. For each action, you also have quite a few descriptors. You have the type of action, you have the result. So if it was a pass, is the result that the player caught the pass cleanly or did they drop it, and so on. And then you also have a spatial component. So X and Y coordinates. For every action recorded, typically there's about 1,500 observations per game. So it's essentially a multivariate time series, very rich data. Unfortunately, it needs a lot of wrangling to get out variables of interest. So I spent a lot of time doing that, using packages like dplyr, reshape, and so on. So what I've been working on at the moment is been using Plotly to basically plot these heat maps. So this is part of trying to visualize this data in a meaningful way. So for example, we have the number of observations per zone of the field. What you have here is the rugby field. You have the actual markings, traditional markings, the 5-meter line, 22-meter line, the halfway mark, and so on. And essentially I've just written some code that you can define how many zones you want on the field, and this one is just showing you basically where most of the action takes place. Then went on to now define a function for the in-game momentum. So the current function that we're sort of playing around with, as I said, involves things like distance from the opposition's try line, the time left in the game, the score difference, the territory gained, and so on. And aside from this graph looking really nice and pretty, this is pretty much what you would expect to see. However, the function we're using at the moment could be argued that it's relatively linear, so there's a lot more work to be done there. Of course, we want to try to relate this to some outcome of success, and in rugby, one of the success outcomes is scoring a try. So here, I have basically plotted the probability of scoring a try. These probabilities are actually smoothed using local polynomial regression with a polynomial of degree 2. And once again, this is, pretty happy with this as a first go. in terms of the correlation between the team's momentum and the probability of them scoring a try. But there is more work to be done, so that one of the next steps is just to include some more interaction terms between these covariates and the momentum formula, and the step after that is to use RShiny to develop a sort of web-based decision support tool, which will include these visualizations and other things to help support strategic decision making. Thank you.